All right, so day 2, simplify. We have 2 monomials, okay? One term is what we are calling these. So in simplifying them, well, first of all, does anyone want to offer up their answer? See if they're right. Morgan, I saw your hand first. What'd you get?
10 times d to the 5th power times e to the 3rd power f times f to the 6th power.
Okay, 10 d to the 5th, e to the 3rd, f to the 6th. Did I get that right? Anybody else have that? Ooh, that's looking pretty good. Nice. All right, well, let's take a quick look. If I could actually read. All right, here we go. So we have 2 times 5, and we take those out front. And then we have d to the 3rd and d squared. Okay, so I put those together. E squared and e. E doesn't have a exponent, so what should I do?
1.
Put a 1 on it. Oh. Did I do that yesterday for you?
Yes.
You're like, yes, you did. Okay, just want to make sure you don't want to miss out on that. Oh, there's an f, no exponent. Put a 1 on it. There you go. Times f to the 5th. All right, so 2 times 5 is 10. And when you are multiplying powers that have the same base, what do I do with the base? Keep the base, right? It's all about that base. And then what do I do with the exponents? Add. Add the exponents, yes. So this is e to the 2 plus 1 and f to the 1 plus 5. And then finally, my final answer, putting this all together, is 10d to the 5th, e to the 3rd, f to the 6th. How many did have that for an answer? Yeah! Woo, the crowd goes wild. Yay! Question? Any questions? No? Okay. All right, so number 2. Now, we did not get very far into scientific notation. We didn't, actually, this class didn't get into it at all, did we? We did read it, you're right. All right, so let's go over this together, and this will be more of a teaching example. Scientific notation is when you have very large numbers with a bunch of zeros or very small numbers with a bunch of zeros. And we want to make it easier to read. You are going to place the decimal point between, no, let me say this differently. You're going to put the decimal point after the first non-digit number, okay? So in this case of 7,500,000, right now, since that is a whole number, there is a decimal point at the end, okay? Same for 2,600. It always falls at the end if you don't see one, okay? But we want to make this into scientific notation, so I am going to move the decimal point after the first non-zero number. Well, my first non-zero number is 7, so I put it immediately after that. What? No. Nope. After the first non-zero number, because you want this first number to be a number between 1 and 10. You want the first number to be a number between 1 and 10. So that becomes 7.5. Please write this down. Brianne, come on. 7.5, and don't worry about the zeros, times 10. Now, to get this from where I moved it to here to its original place, it is 1, 2, 3, 4, 5, 6 spaces to the right. Now, as I go 6 spaces to the right, that is in the positive direction. So this becomes 10 to the 6th power. Okay? And this is the answer for scientific notation of that first number. Okay? Now, my second number is not a huge number, but it does have some zeros in it. But I want to change it into scientific notation. So I'm going to place my decimal point after the first non-zero number. So that's going to be what number? 2.6, right? So this is times 2.6, and it's always times 10 to some power. So you change this into a number between 1 and 10 times 10 to some power. Now, start with where you moved it, and we went 1, 2, 3 spaces to the right. Okay? To get back to my original number. So that is positive 3. Now, it says we are multiplying these. Okay? These two numbers, can we multiply those as numbers? We can't? Yes, we can. So if you've got a calculator around you, can you please take 7.5 times 2.6?
19.5.
Okay, so that's, actually, I'm going to back up. I'm going to write this as 7.5 times 2.6. And you said that was 19.5?
Yeah.
Okay. Now, look, I also have times this 10 to the 6th power and times 10 to the 3rd power. Well, that's just kind of like multiplying our powers that have the same base, right? So I'm going to take this, and this is going to be times 10. They have the same base, right, to the 6 plus 3. I'm just going to write it out, but you wouldn't have to. So this is 19.5 times 10 to the 9th power. Here's my question. Is that in scientific notation?
Yeah.
Yes? No?
Yes.
How many yeses? Come on, take a vote, people. Take a vote. Yes, no. All right, a couple. How many say no, it's not in scientific notation? Why do you say no, Alexandra? Darn it, they always ask why, don't they? Why did you say yes? Those of you that said yes.
Because I looked at the lesson. And
Okay, well, question. Is this 19.5? Is that a number between 1 and 10?
No.
No. So guess what? We need to do scientific notation on that answer again. Don't be fooled by that, okay? Oh, yes, grasshopper. So if I change this into scientific notation, 19.5 becomes 1.95, which means I moved it one place to the right. So that's times 10 to the 1st power. Then I say times 10 to the 9th power, which all together, yes, 10 to the 1 plus 9, which is 1.95 times 10 to the 10th power.
Will this be on
Yes. Scientific notation will be whether we have you multiply and then give you this answer and then you have to figure that out and remember that. Honestly, I don't know right off the top of my head. It's only the second day into this, so. But does everybody see, if you get an answer like this, yeah, it looks like scientific notation, but you have to ask yourself, is my first factor, that first number I'm multiplying, is it a number between 1 and 10? If it's not, you might have to do scientific notation again. Okay? Now, I know that was probably a lot because we actually didn't even go over scientific notation. I did get it started in my other classes. But Let's jump now to, I think we're on page 3, maybe? Page 3 of your packet. And let's go over, oh no,